Today we are going to look at the reduction and oxidation. In particular, we're going to look at the reduction of copper oxide by hydrogen. Copper oxide is black in color, and when it's reduced, it is brown. In order for you to carry out an experiment for reduction of copper by hydrogen, the following apparatus are needed. One reduction tube, boiling tube with a small hole blown out 1 centimeter from the closed end. One hole rubber band to feed the reduction tube, fitted with a short length of a glass tubing. Reduction. Rubber tubing to connect the reduction tube to the hydrogen cylinder or a gas tap. A stand, boss and a clamp. A Bunsen burner. And access to a tap balance that weigh to about accuracy of 0.01 grams. This is the schematic representation. The apparatus when connected together, and this is the photo of the apparatus that we have just seen here in this diagram. This is the drawing, and from the drawing you can see we have gas supply coming in. We have the clamp holding together the boiling tube. We have the heat, source of heat, and also we have a copper oxide. First of all, you weigh the clean, and after you have weighed it, for example, in this video we are saying we have weighed it and it's 28.93 grams. Make sure that it's dry before you weigh it, and you weigh it on a balance that has an accuracy of 0.01. Scoop a spatula handful of copper oxide, put inside the tubing, make sure that it's in the middle. Weigh it again. In this case, it's weighing at 3.03 grams. If the copper oxide is not dry enough, you dry it in the desiccator. You can drive all the water out of it. You are going to let the hydrogen gas pass through and then light the gas. This is done in order to avoid an explosion, because the mixture of hydrogen with air burns explosively. Now when you start heating, I'll look out for water droplets in the cooler parts of the tubing. Also look at the height of the flame. This height of the flame will reduce as you continue heating, because some of the hydrogen gas will be used to reduce copper. And also look at a copper oxide. Always look at the change which the copper oxide undergoes. It turns from black to brown, and continue heating until the entire copper oxide changes completely. Continue heating until all the copper oxide in the tubing changes completely. You remove the heating. Then you don't put off the hydrogen gas burning from the other end, because this will recombine again with oxygen to form copper oxide. So you don't put off immediately. So when it is cold enough, weigh it again. So the reduced copper in this case, it's 32.13. 2.13. Air is driven out of the apparatus by passing hydrogen before starting to heat the metal oxide to ensure the hydrogen is being burned at the jet is pure to avoid explosion. On passing a stream of dry hydrogen gas over hot copper 2 oxide, the black solid changes to red-brown. The red-brown solid is copper metal. Hydrogen combines with oxygen from the copper 2 oxide to form water, which is a colorless liquid. Colorless vapor condenses and collects on the cooler parts of the combustion tube. When hydrogen is passed over metal, overheated copper 2 oxide, it is oxidized to copper metal as indicated in the equation. And there are several things I want us to discuss on this equation. You realize that copper oxide reduces the oxygen, loses the oxygen, and it now becomes copper solid. And oxygen on other hand, hydrogen on other hand, it takes the oxygen that was on copper and it combines with it to form an oxide called water. So in this equation, there is an oxidizing agent and a reducing agent. Also, there is a species undergoing a reduction and there is a species undergoing oxidation. And that's why this kind of reaction, it's called a redox reaction, because there is the reduction and there is oxidation. In terms of oxygen transfer, reduction is the removal of oxygen and oxidation is the addition of oxygen. Redox, as we said, is a simultaneous addition and removal of oxygen. A reducing agent is a species that undergoes oxidation, therefore it gains oxygen, and an oxidizing agent is a species that undergoes reduction and therefore it loses or it donates oxygen. In terms of hydrogen transfer, we can also define oxidation and reduction. Oxidation is the removal of hydrogen from a substance, and reduction is the addition of hydrogen to a substance. Example 2. When hydrogen sulfide gas is bubbled into chlorine gas, it is oxidized, thus it loses the hydrogen to form sulfur, which is a yellow solid. The chlorine reduced gains an hydrogen atom to become hydrogen chloride gas. The equation here shows what is happening. We have chlorine, a gas, being bubbled through hydrogen sulfide gas. Then hydrogen sulfide loses the hydrogen and chlorine gains the hydrogen lost, so it becomes hydrogen chloride gas. In this case, hydrogen sulfide is oxidized, or it undergoes oxidation, and thus it's a reducing agent. And chlorine, in this case, which gains a hydrogen atom, it's an oxidizing agent, and it itself undergoes reduction. The final part is to determine the formula of copper oxide using the data provided from the experiment. We have the mass of the empty tube, 28.93 grams, the mass of the tube plus copper oxide, 33.03 grams, the mass of the tube plus copper metal, 32.13 grams, and mass of copper, we take the mass of the tube plus copper metal minus the mass of the empty tube, we get 3.2 grams. The mass of oxygen, we take the mass of tube plus copper oxide minus the mass of copper, and we get 0.9 grams. Then we proceed to get the formula of copper and oxygen. Here, I will write copper element on its own column and oxygen element in its own column. Then we take and match their weight. For example, copper is 3.2 grams and oxygen is 0.9 grams. Then we divide mass of copper with the relative atomic mass of copper. We are able to get 0.0503, and oxygen, when divided by the relative atomic mass of oxygen, 0.056. Thereafter, we now divide the answers we got here with the smaller number. In this case, the number is 0.0503. And when we divide with that, the ratio of copper, it's 1. And when you divide the same with the ratio of oxygen, so the ratio of copper to oxygen is 1 to 1. The ratio of copper to oxygen in this reaction is 1 to 1. And now we can write the formula of copper oxygen to the ratio of 1 to 1. That's how we determine the formula of compounds, and in this case we have been able to determine the formula of copper oxide.